right?
Well,
Or
one type, you can have different arrays for now. So you can have an array. Let me actually have the camera here. Look on the board. So in case they can see it, let's see. I don't know. Pin the camera. Okay, let's see if I can do. There we go. The board. I'm not sure. So I can have an array of names here. Names, obviously, they're not numbers. Then you can have an array of names here. Come like this. So if I count how many boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I tell the machine that's type string, the machine will take 10 of these rows or boxes and put them aside. The first box is going to be known as names of 0. And the last one here, names of 9. So if I want to put a name in one of the location, I got to tell them which location to put the value in. Now, if I want to read the names, then next to it may be test 1. I can have an array here of test 1. These will be numbers. And again, if you think the teacher is going to give you integer value, we can say this is test 1 of size 10, if they're the same size. I have another array of test 2. Next week, probably, or this week, I'll talk about 2-dimensional arrays. When you have arrays like this, test 2. So this is T2 size 10. So if they're gonna have the same value, eventually we're gonna say, why not create a 2-dimensional array so you can travel up and down, left and right? But what about if you want to put here, for example, Boolean stuff in it? True, false. This is, are you a US citizen? True or false? So you can't combine them together because these are numbers, that's not. Okay. Till we get to records. Then you can make an array of records. You can tell the machine, I want to do a record where the first column is going to be names. The next 2 is going to be test 1, test 2, and the last one is going to be a Boolean. Then you can have one array and it has like different type of things. But for now, no, the array has to have one type of things in it. You know, that's. Any question on that make sense? So I'm just going to show you just to play with arrays today. We'll just take one array and maybe I'm going to do a program here. I think I said last time I talked about something like that. And I said, I'm going to ask the teacher, how many students you have in the class? And based on that, we'll make the array as big as that. Then I'm going to put numbers in it. 50, 60, 70, 80, 100, 90, 40, 35, 92, 84. Then I'm going to calculate the average. If the average is below 75, I want you to go back and give each one 5 points. So this one becomes 55. This one becomes 65, 75, 85. 100 stays 100. You can't get more than 100. But the 90 becomes a 95. The 40 becomes a 45. This becomes a 40. That's a 97. And that's an 89. You're only going to do that if the average is actually below a 75. If it's above 75, you don't touch them. They stay the same. So maybe we'll do something like that. Okay, let me open. Okay. Let me stop sharing. Was I sharing? I don't think I was sharing. Okay. Got you. And where is C++? And Control N for file new. Is it Control N? Control N. Yep, it is file new for control. So what I'm going to do here, just quickly to write, create an array of any size. That means the user will specify the size. Then we're going to read all the values. And we're going to save them into the array. We're going to calculate the average. If average is less than 75, add 5 points to each one. And just keep in mind, max score is 100. Can't get more than 100. That's your max score. And maybe we'll show the result before and after, you know. And let me end that one. Okay. So when you have multiple comments, instead of using double slash, double slash, double slash, you can do that. And that just slash with an asterisk that tells the machine, ignore all of this. This is not for you. It's not for the machine. This is just for you and I. Okay, let's begin. Pound include IOStream. Where'd you go? There we go. Sitting way far. Oh, I know how. I can bring this one closer. Let's see. Hey, what did I do? Pound include IOStream using namespace standard. INT main, the usual stuff. Curly bracket to open it. Return 0. Okay. This desk, stand up. Sitting down is not comfy. So let's create the array. That's the first part. Well, I can't really create the array till I know the size. So maybe I should do ask for the class size. And you want to validate that? Maybe we should. How big do you think the largest class? How big? You have a number in mind? Anyone? 60 students? Okay. So let's define int size. So let's ask do. I'm going to say do here so I can have them go through the loop once, then I'll validate it after. Cout. Enter. Oh, double quotation. Enter the class size. So this will show up on the screen. And now we're going to read that one, CN. And we're going to read the value for size. And if that value is negative or more than 60, it's not a good size. Repeat this while what? While size equals I'm going to say equal, less than 0. Or it could be less than or equal. If it's equal to 0, you don't have any class there to calculate the average, nothing. Or size is greater than, you said 60. If you have more than 60 students in the class, something is not right. On campus, you'll be safe here. We do not have any class more than probably 40. 32 is really the maximum by union. Sometimes I let people say, do you mind if this one sit in the class or that one takes the course? I say, fine. So I'll allow 3, 4 people, but most of the rooms don't hold more than 32 here. So if you count, it's probably 32 seats here. Once we have the size, so when you exit this loop, that means you know the size and you have a valid number. Now we can create the array. Maybe I'll do 2 arrays, one before and one after. Before the adjustment, after the adjustment, you know? So let's create that. Do you think can the score be decimal values? Possible, right? Maybe. I'm not sure. But why lock yourself to integer? What happens if you got a teacher that uses some software that actually gives you a score of 59.6 or 63.4? So instead of saying the score is going to be integer, we'll say it's going to be decimal values. And if they are integer, so what? You know? So let's create an array for that. So we'll say double. I'm going to create 2 of them. I'm going to call one the before, and that's size of how big. That's the size. And I want to create another one, comma. The after the adjustment, we'll make it the same size.
You have to increase the size in there because the index starts at 0 and then.
Just when I type them, I go student 1, but I'm going to put for 1, I'm going to put in location 0. As long as you know that. Some people go +1, so 1 goes in 1, 2 goes in 2, but they're not using the 0. You know, so I've seen people do that, but I know, yeah, student 1 is going to go on location 0, student 2 is going to go on location 1. So always 1 below that. Yeah. So now let's load the values. We need to make sure that the numbers also we type in are good numbers, right? So let's set up a loop here. Load the array. I'm not going to worry about the numbers yet. I'll come back and fix that. 4, because I know exactly how many times. int k equals to 0. Is that lowercase k? It looks like lowercase k. K is less than the size. As long as you're less than the size, k plus plus, each time increment by 1. If I go read them, curly bracket to open, curly bracket to close it, C out, enter, student, and here, and this where I'm going to be tricky. Well, I'm going to say k plus 1 there, because the first location k is 0. There is no student 0. So I'm going to say k plus 1 here. So k plus 1 goes into location 0. K plus 2 goes into location 1. Enter student 1 score. Oh, come on. Space score. Space. Enter student 1 score. Enter student 2 score. Enter student 3 score. And let's read them. CN. And you want that to go into the array before. before in location K. Again, K is 0. So the first one goes in location 0, but that's for student 1. K is 1. Actually, that's student number 2, really. But it goes in location 1. Student number 3 goes in location 2, and so forth. Just to show you if this is working, just to make sure it's doing what it's supposed to do. Today's date is March 30th. March 30th. Cinco de Mayo is coming soon. They usually have food on campus for Cinco de Mayo. They have music and different things. I didn't see anything. I didn't check the flyers on campus, but let's see if this is working. Do it. It's up. Initial the size, integer size. I forgot the semicolon here. While size less than 0 or equal to 0.
Yeah, you forgot it again in the CN.
Oh, yeah. Thank you.
And I believe you made a lowercase size somewhere in your program. Yeah, for loop.
Good eyes. Let's see if that's double before size. Double, I just don't see it. After size, let's see. Sometimes my eyes deceive me. Before. Let's see. Expected is a semicolon. Oh, right there. So how many students in the class? I go 200. Can I say nope? Minus 50, nope. 3 people, because I don't want to type a lot of numbers. Notice enter student 1 score, 85. Enter student 2 score, 76. Enter student 3 score, 84. So student 1 actually is going to go in the before at location 0. Student 2 is going to go in the before at location 76. I mean location 2. And student 3, the 84, is going to go for location 2. In that array, the first one is location 0. But here it says 1, 2, 3. The one thing I did not do here, check to see if the score is above 100 or below 0. So let's check for that. So for each one of these, let's hold the number first. Well, it doesn't matter. Do what? As long as the score now, here we go, there's the while. While the value in location, where'd you go? Here we go. In location before K, in location K. You know what? I don't like the way I'm doing it. I'm going to do it different. I'm going to just create a temporary one. I could do it this way. I just don't like it. I don't want to put in the array. Let me just go down here. And let's do this. Curly bracket. Let me create a dummy variable here. Double temp for temporary. Create a dummy variable. Read the score. That's too much typing to write there. Put it in location K. I mean temporary. Hold it for now. While temp is less than 0, or temp is greater than 100, ask for the score again. So once you exit that, once you exit this loop, once you reach this point, that means your score is good. So what I want to do here, I want to let before location K is equal to temp. Take that value that you just read there and save it now. We know it's good. Notice this one here closes that one. So when you're inside this loop, I'm just checking to make sure that score is good. Once the score is good, then the machine says, okay, what do you want to do? Once the score is good, get out of this inner loop, get out of this and go right here and save it now. And go back to this loop. K becomes 1. Get the student. Here we go. Let's test it. Just to show you. How many students? 3. Student 1 score, 105. That's not a good score. No, it's still asking for student 1 score, minus 50. Nope. 76. Now that's a good score for student 1. It's going to go to student 2. 200. That's not good. Minus 17. Nope. 33 is good. It goes to student number 3 now. 84. Now we got them all. So each time you get a score, we test it. We make sure it's between 0 and 100. Okay, so this one actually does load the array. Now the next piece here, calculate the average. That means I need a location to have the sum for me. It's going to add all the scores. So here we go, double sum equals to 0. Start with that being 0. There's nothing. I want to add all the scores and add them. Set up a loop for int k equals to 0. K is less than the size k plus plus. And what do you want to do? You want to add all the scores. Sum equals sum plus the before of k. So take the value in location 0, add it to the sum. Take the value in location 1, add it to the sum. Location 2, add it to the sum, till you add them all. Once you have them all, that average, double AVG for average, equals the sum divided by the size. How many students in the class? We added all the scores, divide them by the number of students. And that should give me the average. If what? If average is more than 75, more than or equal to 75, you're not getting any points. Nothing. So what do you want to do if that's the case? You want the after to be the same as before, right? So I can do 4 because there's more than one location. I got to set up a loop. int k equals to 0. K is less than the size. I should just copy that and paste it. K plus plus. And we want the after of K to equals the before of K. Well, the after be the same as the before. So this section here is going to adjust the score if necessary. Come on, this one. Nope. Adjust score. Okay, we'll just call that if necessary. So if the average is above 75, do this. But if it's not, else. Don't you want to do all of this? Add 5 points, copy, Control V. The after K equals the before K plus 5 points. Take the before score, add 5 points to it, and save it. But remember what I said, nobody can have more than 100, right? So I got to fix that. I got to check, make sure here that score is not above 100. So I'm going to do 2 things. That's why I need the curly bracket. It says add 5 points. Then after that, if the new score, which is in location what? This is after of K. I hate that. Greater than 100. If it's more than 100, then just make it 100. So we want the after K. And that's the end of the curly bracket for that one.
Oh, I see. So like if it's a 99, it's gonna add 5, but then it's gonna
Okay,
go
yep,
back and
yep.
change.
Yep, I'm just adding the 5 points. You can check first and but this one just adds 5 points and it checks it. Okay, yeah, it's above that. Let me just make it, you know. So that should actually adjust all the scores. And finally, you want to print the before and after? You want to see them side by side? Print the 2 arrays, the before and after. Control K, Control V, I mean. See out. You want to do them side by side or on top of each other?
Side by side.
Side by side, okay.
You label the columns.
You can, yep. We can label them. You want to do the before. Then after that, we're going to say the after. And go the next line. And L. Then C out. You want to make it nicer. How about we'll put even lines under them. And L. There's one little problem here. This is gonna write that every time. Like if you have 50 students, it's gonna write that 50 times. I wasn't planning on doing that, so let me cut this one from here. It's just the header. So now I want to do that. I want to write the before and after. So for the before, we're going to write C out. We'll do the before. Okay. Then after that, I don't know, some spaces there. Oh, double quotation. Put some spaces like this, I don't know. And this is the after.
You couldn't use like your set precision with these or.
I could set precision, set width and all that.
I just
Sure.
didn't know
Yeah.
if it worked
Oh,
the
yeah.
same way.
Oh, yeah. Everything still works the same. And L. And that should print them. If you want to use a set precision, set width, and all that stuff, still good. Let's see if this working. K is less than this capital S,
Okay.
capital S.
Slash there.
Oh,
And your second for loop.
I did this when it was also lowercase, but let's see now. C out for INT before K. Oh, I forgot the after. How many students? Let's have 7 students. Let's say the scores are 89, 90, 92, 93, whatever, 86, 78, and 100. That's 6 of them. I need one more. And 97. Now it looks like the average is going to be more than 75 here. So there'll be no adjustment to the score. Notice if you're not using set precision, set width, that 100, you could shift it to the right a little bit there. Where if you do set precision and set width, then they'll line up nicely. What happens when the scores are below 75? And let's see. Let's run it again. And I get a 50. Oh, oh, no. How many students in the class? 5. 50. 100. Oh, let's do this. And then instead of 198, that 45, 70, and 60. And notice there's the before and the after. 50, 55, 98 becomes 100 because you can't have more than 45 becomes a 50, 70 becomes 75, and 60 becomes 65. Yeah. So you treat them just like treating any other variable, except you have to put square bracket, tell them in which location you want to do the work. Like here it says, I want it when K is 0, I want it to go in location 0. Then K becomes 1. What's in location 1? What's in location 2? Location 3. That's how you have to set them up. If you ask the machine just print the before without the K, you get a syntax error. The machine doesn't know what that is. The before. It's a block of them. It will not print them all in one shot. How big? I say I have 6 students. Score 1.
It's still accessing the array even inside the brackets.
Well, that's initially loading them till
Oh,
I go to print. And when I went to print, notice that before, look at the gibberish stuff I got there. Yep. Because it doesn't know what we're talking about. So everything was okay. I'm reading the stuff. Reading was fine till I get to the print. And I go print the whole array here. And the machine goes, I don't know what you're talking about there. So you have to specify which location. Just like when you read them, you have to tell the machine where you want to save it, which one of these locations.
if you, I'm just trying to think, like, some other computer programs would probably not compile or.
Well, I was expecting that to compile, actually. I was expecting that to compile. But it did compile because it knows before is an array. So it just waited till it got to it. But I was expecting to come syntax error.
Me too.
Yep. And by the way, there's different companies that make C++. Some of them might actually not compile. Might tell you, hey, no, you got to specify that. But one way or another, doesn't matter which one you use, they can tell you something is not right if you leave it without the K there. Let's see, any questions? We got about a minute left. I look at the clock when I'm lecturing, I start to speed up sometimes. I'm looking just making sure. We good? Everyone's good?
I know I keep asking about this capstone thing, but like, what? I'm wondering, and my mentor and I are wondering, what program size are you looking for? Like algorithm size? How in depth are we getting?
Well, the better the program, the higher the score.
Okay.
Does that make sense?
Well, that's the thing. He's
It-
like, well, a lot of this, you're thinking about.
But the stuff
you know,
we use them, like if we didn't use the stuff, I don't want you going there and start digging, for stuff
I
and
guess, well, I was thinking, like, what if I asked the computer how many, like, calculating the area of a polynomial if you're giving the side, how many sides you have and the length of the sides. It's like, that'd be something accessible, like,
any polynomial.
well, up to a certain like amount, just so it doesn't like.
You have to have like if it has this side, if it has, you have to know all the math equations for them too.
Well,
So
if not, if you're breaking them into like triangles.
triangle, yep. Yeah, if you break them to triangles. So if you have 4 sides, what's that, 2 triangles? Is it always 2 less than that?
I don't remember. I just was wondering if that's something.
Let me
that
just
you
end the
think would be
recording.
Pretty acceptable for.
Let me end this one. Oh, no, cancel. Oh, this is fine, yeah. This
Cause
is,
I also want to keep it in the scope of a 101 class,
yep. Wait, the math, curiosity in math. I love math, so I